Let's see another environmental pollution as smog. What is meant by smog? Smog is a mixture of smoke and fog. Smoke and fog together you can call it as a smog. This is the most common example in the air pollution or as an air pollution in many cities throughout the world. Smog actually consists of classical two types. You can divide smog into two types. Classical smog, it is also called reducing in nature, reducing smog. Second one, photochemical smog, which is oxidizing in nature. So this smog you can make it into two types. One is a classical smog. It is also having a nature reducing, so it is called reducing smog. And second one, photochemical smog. Its nature is oxidizing, so you can call it as oxidizing smog. So the mixture of smoke plus fog equals to smog. Smog is of two types. One is reducing smog, it is called classical smog. Second one is oxidizing smog, it is called photochemical smog. Classical smog or reducing smog, how it could be produced and what is the danger because of this inhaling of this kind of smog, let's discuss now. Classical smog occurs in the cool, humid climate. This is number 1 point. Number 2, it is a mixture of smoke, fog and SO2, sulfur dioxide. Mainly that it is having a mixture of smoke, fog, SO2, sulfur dioxide. Okay. Chemically its nature is reducing in nature, it's reducing mixture, and so it is called as a reducing smog. We can call it as a reducing smog because of this. Now let's see photochemical smog. What is photochemical smog? Photochemical smog, where it occurs? It occurs in the warm, dry and sunny climate, opposite to this reducing smog. The main components of the photochemical smog or oxidizing smog resulted from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Unsaturated hydrocarbons like alkenes, like alkynes, like any aromatic one, unsaturated hydrocarbons in the presence of sunny climate or sunlight, okay, and also along with nitrogen oxides produced, which is released from the automobiles and factories. The photochemical smog has got high concentration, high oxidizing nature, concentration of oxidizing agents such as this nitrogen oxides. Therefore it is called oxidizing smog. It can be called as oxidizing smog. So this mainly consists of photochemical smog, mainly consists of it is unsaturated hydrocarbons plus oxides of nitrogen along with smoke and fog, along with smoke and fog. So this nature is oxidizing, so it's called oxidizing smog. This nature is reducing because of SO2, so it's reducing smog. Its nature is oxidizing because of oxides of nitrogen. And how do you get it? The main components, what are the main components in it? Photochemical smog results from the action of sunlight on the unsaturated hydrocarbons and also nitrogen oxide. These are responsible for oxidizing nature. So that is what you can say, you can understand as a photochemical smog. So the one is reducing, this is classical one. The one is oxidizing, which is a photochemical smog. Itself you can understand, photo means light, and you can see formation of photochemical smog, how it is produced in the atmosphere. Let me discuss a point about it clearly. Nitrogen, which is present in the atmosphere, absorbs energy from the sunlight. It absorbs the energy from the sunlight and breaks up into nitrogen dioxide, NO2, not nitrogen. Nitrogen dioxide absorbs the sunlight, energy from the sunlight, and breaks up into nitric oxide, NO, and free oxygen atom. This is what first step. These free oxygen atoms are very reactive, highly reactive, and they combine with oxygen present in that air to produce into ozone. Ozone is produced. This is what you can say as a step 2. So in step 1, nitrogen dioxide absorbs energy and it will break up into nitric oxide and free oxygen atom. Formation of photochemical smog, you can understand. Step 1, nitrogen dioxide absorbs energy from the sunlight and break up into nitric oxide and highly reactive gaseous oxygen atom. This is step 1. Step 2, this highly reactive gaseous oxygen atom reacts with the oxygen present in the atmosphere or air and is converted into ozone gas. This is step 2. By this way, you can understand the formation of photochemical smog. Step 1, absorbing energy, breaking into NO and O. O absorbs or reacts with oxygen present in the atmospheric air and forms ozone gas. This ozone gas, which is produced over here in the above reaction, you can say reacts rapidly with the nitric oxide produced again here. With the help of this ozone, this ozone will react with the nitric oxide produced, which is there in the first reaction, regenerates nitrogen dioxide. This nitrogen dioxide is a brown gas, reddish brown gas, and is sufficiently high in the concentration level, can contribute to atmosphere, or it will become a haze, contribute to, it will damage. So this produced ozone, you can say, reacts with nitric oxide of the equation 1. Now will be forming again as a nitrogen dioxide gas. This nitrogen dioxide, which is there in this highly sufficiently concentration levels, it causes or can contribute to haze. This is what you can say the photochemical smog damages the environment, or it causes the, it will become a curse to the environment, I can say now. So this ozone is a toxic gas. Ozone is a toxic in nature. The ozone basically is a toxic gas, and both nitrogen dioxide here, NO2, and O2, which are there, are strong oxidizing agents and can react with the various unburnt hydrocarbons. React with unburnt hydrocarbons in the polluted atmospheric air, produces chemicals like formaldehyde. They produce what? Next step is formation of formaldehyde. So this unburnt hydrocarbons combines with the oxygen which is produced over here. This oxygen combines with methane, for example hydrocarbon, and it will produce formaldehyde. And another example I can tell you, and acrolein. Acrolein is produced, and also another example I can tell you, peroxyacetyl nitrate is produced. Let's see, for example, this unburnt hydrocarbon methane reacts with the oxygen produced in the equation 3, combines with oxygen and form a compound called CH2O. This is called HC double bond OH. This is nothing but HCHO. All are one and the same. This is called methanol. This is IUPAC name. Common name is formaldehyde. This is a formaldehyde. So it will produce 3 moles of CH2O or HCHO, or all are one and the same. You can write. and side product will be 3 moles of water. Like this, you can see unburnt hydrocarbon combines with the oxygen produced in the equation 3, forming organic compound formaldehyde. Not only this, it is also forming another compound, acrolein, CH2 double bond CHO. This is acrolein. This is another example formed due to photochemical smog. Another example also we can give as peroxyacetyl nitrate, PAN. Peroxy bond will be there, acetyl group is there, and nitro group is also there. This is called PAN. Example, CH3 C double bond O and OO peroxy linkage and NO2 group. So you can see this is peroxy linkage, this is acetyl group and nitro group. You can call it as a peroxy acetyl nitrate. This is called PAN. The expanded form of the PAN is peroxy acetyl nitrate. This PAN is given a structure like this. This is formaldehyde, methanol, this is acrolein, and this is a peroxyacetyl nitrate, PAN. This is produced, okay, because of the photochemical smog, oxidizing smog. It's all because of unburnt hydrocarbons. So like this, the formation also you can understand, and if at all any related questions they can ask you on this. So they can ask you a question like this: photochemical smog occurs in, okay, photochemical smog occurs in options: warm climates, cold climates, both, none. Photo means light. Light means what? It occurs in obviously warm conditions only. So we can go for answer as warm climates if the question asked like this. Then if at all a question asked like what is meant by PAN? What is meant by PAN? So you can see what is PAN. PAN is nothing but peroxyacetyl nitrate. What is the structure of PAN? This is the structure: CH3 C double bond O, OO, NO2. What is the nitro group? NO2 group. NO2 is nitro group here. So this is a functional group here. Okay. So what is the PAN formula? You can see 1, 2 carbons. Hydrogens, how many? 3 hydrogens, 3 oxygens, and 3 plus 2, 5 oxygens and 1 nitrogen. Like that they can confuse you by giving the formula of the PAN. So this is what peroxyacetyl nitrate, or you can call it as a PAN. Okay. And now we will move to other concepts of the topic. So we have discussed about how photochemical smog is produced. Now we will see what are the effects of photochemical smog. Effects and control. How do we control photochemical smog also we will discuss now. Let's see what are the common components of the photochemical smog. You can say number 1 ozone, number 2 nitric oxide, number 3 acrolein. Just now I gave the structure of acrolein. Number 4 formaldehyde, number 5 peroxyacetyl nitrate, you can call it as a PAN. Both ozone and PAN acts as a powerful eye irritants. Ozone plus PAN, these two are eye irritants. They are powerful eye irritants. They cause powerful eye irritation. Ozone and nitric oxide irritate the nose and throat, and their high concentrations causes the following effects: headache, chest pain, dryness in the throat, and cough, and difficulty in breathing process. So the mixture of ozone and nitric oxide mainly troubles the nose. It will trouble the nose, and ozone plus PAN troubles the eyes. They are eye irritants, and ozone plus nitric oxide mixture mainly troubles the nose and causes even other effects I have told you just now. Now let's see, photochemical smog leads to cracking of rubber in the rubber industries and extensive damage to the plant life. It is also another damage, okay, even for the it will damage even to plants also. This also causes corrosion of the metals. Metals may be corroded because of the photochemical smog. Stones may be damaged, building materials may be damaged, rubber structures may be damaged, and painted surface also affected very badly because of the oxidation or oxidative smog or photochemical smog. So this is what extensively we can discuss about photochemical smog. Then the question will come, how do we control the photochemical smog? We can control the photochemical smog like this. If we could able to control primary precursors, what are the primary precursors of the photochemical smog as far as the discussions are made here? Like nitrogen dioxide and hydrocarbon. These are the primary precursors. These primary precursors, if at all we can control them, we can definitely control this release of photochemical smog or particles into the atmosphere. And when you can control the primary precursors, obviously the secondary precursors like ozone, pan, the photochemical smog will be automatically reduced. So it depends on primary precursors over here. What are the primary precursors in this? Primary precursors are ozone plus hydrocarbons. What are secondary precursors? Pan and ozone. So if at all you can control the primary precursors entry into the atmosphere, that is NO2 formation, hydrocarbons reaction, we can control obviously secondary precursors, formation of pan and mixing with the ozone, formation of ozone, etc. can be controlled easily. By this way we can control the photochemical smog and the adverse effects due to it. Another method also there, we can control the photochemical smog formation, that is we have to use catalytic converters in the automobile industries or automobile vehicles, which prevents the release of nitric oxide and hydrocarbons to the atmosphere. Primary precursors reduced, secondary precursors automatically decreased, and also catalytic converters, if at all you imply in the vehicles, they will not allow nitric oxide to release into the atmosphere obviously, and formation of nitric oxide, hydrocarbons entry into the atmosphere can be minimized, I can say. So by this way you can control the photochemical smog and the adverse effects due to photochemical smog. And also we can think like this, by the growing of some greenery, like by growing some plants like pinus plants, particularly by growing up of the pinus plants, it will absorb nitric oxide and hydrocarbons easily when compared to the rest. Therefore this pinus, juniperus, another example I can tell you, plants like pinus, juniperus, quercus, another plants, quercus, they will, pyrus, another example, pyrus also we can take, and vitis. These are all examples, 5 trees, 5 plants, pinus, juniperus, quercus, pyrus and vitis. These are all can be grown extensively. They remove the release of or released NO or nitrogen oxides and ozone, hydrocarbons can be absorbed by them. By this way we can control the photochemical smog. So they can ask you a question, what are the primary precursors in the photochemical smog? You can answer easily. Primary precursors are just now I have given on the board, nitrogen dioxide and hydrocarbons. They can ask you what are the secondary precursors. The secondary precursors are pan and ozone. They can be considered as a secondary precursors. They can ask you a question, corrosion of the metals is caused by photochemical smog, carbon dioxide, ozone, carbon monoxide. If at all options are given like this, which option do you go? As per as the discussion which I have made now, you can say photochemical smog is responsible for the corrosion of the metals. Even the leather is cracked, rubber is cracked, all these consequences just now we have discussed. Therefore we can go for corrosion of the metals is done by photochemical smog. Like this we can analyze our knowledge by posing such kind of small simple questions at this level. Okay, let's move to the next concept.